Upload your doubts on the app to get video solutions.
A uniform chain of mass m and length L is lying on a horizontal table with 1/3 of its length hanging over the edge of the table. If the chain is in limiting equilibrium, what is the coefficient of friction for the contact between table and the chain? Okay, so let's try to first understand the concepts here. So see here, this is our table. Okay, one second. This is our table over here. Okay, and this is our any string. Okay, a chain. So this chain is lying here. 1/3 of the chain is here below the table, hanging here. So what part is on the top of the table? 2L by 3. Sir, how do you know? L minus L by 3, which is 2L by 3, right? Or you can directly add both of them, 2L by 3 plus L by 3, that will give you L, correct? Okay. So mass we have to figure out, because that's a very important concept. We can't say directly mass will be this much, okay? We will see, because the mass of the whole portion is M. So we will see how much mass is over here, correct? We will find first mass per unit length for that. Okay, so first of all, we can say that if this is L by 3 and that is 2L by 3, the total mass, total length of the chain is equals to L, and the total mass of the chain is equals to M. So mu, we call it as mass per unit length, that will be equals to M by L. This is a parameter. Mu is mass per unit length. What will be the mass of the upper part? The mass of the upper part will be, let's call it as M1, let's say. This mass of this part is M1 and mass of this part is M2. So that later on when we will draw the free body diagrams, it will be easy for us. So mass M1 will be equals to mu times L1, correct? And what is mu? M by L. And what is L1? 2L by 3. So this will give us 2M by 3. This is our mass of the upper part, okay? Let's figure out the mass of the lower part. It will be M2, that is equals to mu times length L2. What is mu? M by L. And what is L2? L by 3. So the mass of the lower half will be M by 3. Correct? I hope this is clear. Now let's draw the FBD, free body diagram, of the upper half, which is placed on the top. So here upper half is this one. Downward the weight is acting on this mass. And what is the mass M1? Let's call it as M1G. M1 is 2M by 3, right? We will substitute later on. Because of that, there is a reaction force upward, which is normal reaction. And right hand side, there will be a tension in the string T, correct? And if the tension is there in the string right hand side, the friction is acting on the left hand side, which is how much? Mu, and let's call it as F only, frictional force, correct? So these are the forces acting on the first part of the chain, which is lying on the top, okay? So we can say that N is cancelling out M1G. So N will be equals to how much? M1G. M1 is 2M by 3G. This is our N. And tension T in this whole chain will be how much? Frictional force, which is F. And this implies T will be equals to mu times N. And that is equals to mu times, what is N? 2mg upon 3. Correct? So this is our tension in the string. Let's draw the FBD for the lower half. So for the lower half, there are only two forces acting here. One is M2G downward and another is tension upward. So this tension is the same as the tension in the upper half, right? So this will give us tension T will be equals to M2G. This is the equation for the lower half, okay? This part of the chain, the lower half of the chain. And T, we just now found, it is equals to 2 times mu mg upon 3. That is equals to M2. What is M2? M by 3. I hope this is clear. Let's cancel out both. So on cancelling out, let me rewrite the expression here. 2 mu mg by 3 is equals to mg by 3. Let's cancel out mg by 3 both the sides, and mu will be nothing but 1 by 2. This is our coefficient of friction.
Watch the complete playlist on the app Pions. Download the app now.